Introduce James Dyson, Sir James Dyson, Knight of the Realm, and consummate inventor who came out with the first bagless cyclonic vacuum cleaner about 20 years ago, and has since disrupted all sorts of other consumer electronics categories with the fan and the air blade, which sounds like a 747 taking off. All amazing products. So I thought we would just get started because the product cycles seem to be shortening, and everyone expects you to come to market with something very quickly these days. And yet you spent two decades, possibly, in your garage tinkering before you came up with your final prototype. Will you tell us a little bit about that?
Well, it wasn't 2 decades, but it was 5 years.
Oh, well, 5 years.
And I built,
in product
I built
time,
5,127 prototypes. I always say, I'm a huge failure because I did 5,126 mistakes. But no, it took a long time, and things do. I mean, we're developing battery technology that won't be out for 15 years. And our electric motors, digital, very high-speed electric motors, they took 10 years before we got them to the market. But when it gets there, instead of being like that and clunky, it's tiny, it goes 110,000 RPM as against the 30,000 RPM. It's twice as powerful and lasts almost forever. So it's a much, much better product, but it takes time. And you have to have big development teams doing it.
Sure.
But there's nothing wrong with things taking time.
I agree, amen. So, but when you did come out with this vacuum, it was an incredibly disruptive technology. I mean,
we made a few enemies.
I would imagine the Hoovers of the world were not too pleased. So what kind of resistance did you meet when you came out with it?
Well, the retailers sort of didn't understand it at first, but when they did, they were very supportive. The competition ignored it, hoping we'd go away, and gradually, one by one, they started copying it, and we had the usual thing of having to sue them. But I'm not, unfortunately, because in America, you spend, I think it's 4 times as much on lawsuits as you do on research and development. So it's not a good situation. It's a pity because Americans love technology. So researching and developing technology is much more interesting than fighting lawsuits. But
there it is. But you were really trying to solve a problem, a common everyday problem, which is that vacuums sucked up dirt and air and dust with bags, and you removed that problem. Do you see all design as a matter of everyday problem solving?
Well, for me it is. I'm just an ordinary person. I was a designer, and I went and trained as an engineer. And I get angry about things that don't work, hand dryers. I've gone into laboratories and washed my hands, and then I've gone and there's endless paper towels, which I think are a huge waste of paper towels. And those hot air hand dryers, you stand there for ages and then give up, wipe hands on your trousers, and you walk out. So we got angry about that, and we were messing around in the labs with another product that used a high-speed blade of air. And we thought, wouldn't this be the way, to scrape water off your hands with a blade of air, rather than using all that heat to try and evaporate the water, and by the way, chap your hands in the process.
Right.
So we came up with the technology. It was made possible by, again, a high-speed digital motor there, which again goes at 110,000 RPM and develops incredible pressure. So we get pressure to come out of this 0.3 of a millimeter slot here. And it's literally like a windshield wiper. It scrapes the water off your hands. It's quite a nice feeling, actually. So you see the skin rippling a bit.
Yeah. Yeah, the torque of that thing is incredible. I mean, it really feels like a race car.
Well, it saves a huge amount of energy, you see. It's 1/6 of the energy of a hot air hand dryer. It's 12 seconds, not 40 seconds. And it's 3 times as environmentally friendly as hand towels. So actually, that's not the reason we did it. We did it because we wanted to dry our hands quickly. But as it turns out, it saves a lot of energy and a lot of carbon footprint.
So then you didn't start out wanting to design a green product. It just ended up being a byproduct of the good engineering?
No, we never do that. I hate greenwash. And the thing is, I employ young engineers. I always try and get graduates. And graduates are very idealistic. And they've been taught lean engineering at college. And I love lean engineering. So what we do is lean engineering. So our latest vacuum cleaners use far less plastic and are far lighter than the early ones, which doesn't make them any flimsier because we do really, really extensive testing trying to break them. But it means they're lighter and use less energy to make them and less plastic. And of course, they're cheaper to make. So we can, because of that, we can put in more technology, which we otherwise wouldn't have been able to do. But that's what engineers do. They're not marketing people with greenwash. They're engineers doing lean engineering, which they find exciting.
So let's talk about your engineering team then, because now you are, of course, an international company and very well established. And you have how many people working for you?
Nearly 4,000.
4,000 people. So how do you continue that spirit of innovation, disruption, when you have 4,000 employees?
Well, I try to always employ graduates because they have no fear, they have no experience. I don't want experience. I want people who haven't done something before and want to find a new and better way of doing it, and who have no fear of failure. Because failure is so important. I mean, it's what you learn from it. If you always succeed and always give the right answer, you're learning nothing.
Right.
So I want people who feel as though they're pioneering and want to do something in a different and better way. And the funny thing is that these graduates, and when they become managers and they want to employ someone, they always say, I want someone with experience. And it's laziness. It's because they think that the person coming in won't need to be trained, won't need to be helped, which is, of course, quite the reverse, because you've got to knock their experience out in order to get them back to be thinking originally. Graduates are good straight away. You don't have to train graduates. They're brilliant straight away. I remember when I first started and I was making an upright vacuum cleaner. Most of the world buy canister vacuum cleaners, so I had to develop a canister vacuum cleaner. But my few engineers, all 5 of them, were busy on the existing product. So I just hired a graduate straight from the Royal College of Art, where I came from. And I said, get on with it. You and I are going to do a canister vacuum cleaner together. And that's what
lucky
we did.
guy.
And it's the one sitting in MoMA, by the way, that one. So that was a graduate did that.
So how early graduate? I mean, they've gone through graduate school, or they're just like fresh out of college?
Fresh out of college.
Fresh out of college.
Yeah.
Hire young.
And you don't have to train them. The worst thing to do is to train them. Just get them doing something. And it's brilliant what they do. I mean, I don't have the ideas any longer. They all have the ideas because they have no fear, no experience, and they're really enthusiastic, and they want to change the world.
So you really encourage them to just fail their way into success.
Yes, and I want to see their failures because that's what you learn from. I would say if you go to a golf club and you sort of look at it, you learn nothing. If you break it over your knee, you learn the strength of the golf club and what its yield point is. So failure is terribly important. It's terribly important in schools as well. I mean, the problem with schools is they only teach you to give the right answer, and you're bright if you give the right answer quickly. They don't teach you to learn by experience or learn by failure and have no fear of failure. There's very few jobs in life where you know the answer before you do it.
Right.
You have to work it out. If you're an author or whatever you are, you have to work it out. So why don't we teach people at school to have failure and learn by experience?
And you have a foundation which is trying to encourage young people to get into engineering. I know that there's a dearth of engineers coming into the market in the UK. There certainly is in the United States. And meanwhile, 40% of the graduates in Singapore are engineering graduates.
Yeah, and 30% in China. Yeah, no, we haven't got it here yet. I mean, the problem with the global marketplace is that everyone can make something. A lot of people can make them cheaper than we can. So to be successful, we've got to develop something they haven't got that the world wants and which you can patent so the Chinese can't copy it. So it's R&D, research and development in employing engineers is much more, and scientists, is much more important now than it ever was in the past. And the shortage is going to be astronomical. I mean, we have German companies like Siemens coming to poach our engineers, over to England to poach our engineers. The shortage in Europe and the United States is a really serious problem. And we can't go on as we did in the past, producing Me Too products like everybody else. We've got to produce products that have far better technology and which everybody wants to buy. So, and the problem is that, 30% of girls at school want to be models. I was quite encouraged by the figure of 13% of girls want to become scientists, till I learned that they all wanted to be pathologists because of the CSI program. So the thing is, we're not, in schools, we're not getting children to see the excitement and fun in engineering and in making things. The line is that manufacturing is repetitive and boring. Modern manufacturing is not repetitive, I can assure you, it goes wrong all the time. And it's certainly not boring, it's very exciting because you're having to introduce automation and all sorts of exciting things. And you're making things all day long, and what could be more creative than that?
So is there a lot of tinkering and making happening kind of out in the open air at Dyson HQ?
Yes, I mean, we have 2,000 engineers, and we don't have too many projects. We try to concentrate on projects. But, we're not going to produce a product like anybody else's, or one which only has a marginal improvement. We want a big improvement. And if we have a big improvement, then we can go and sell it in Japan, which is our second largest market, and over here, because you love technology here. And we can charge a lot for it, and then make a lot of money. And that's important. There's no point in doing a business if it's not going to make a lot of money.
So let's talk about some of the other toys on the stage here, because really, with every product release, you disrupt another industry. And, this is the fan, which...
Well, I've had to sort of shriek at and stop my grandchildren shoving their fingers through the grill in a fan. This blade spinning around at high speed, really dangerous. And a friend of ours had their finger chopped off. Their daughter had their finger chopped off.
And this has
also
no blade,
impossible to clean. And also the blades chop the air, and you get this sort of buffeting. Sounds slightly esoteric, but it's actually true if you have it playing on you for an hour. So this is... I don't know if I can switch it on. There we go. So there it goes.
You feel that?
What? There it is. It takes in a very small amount of air here in a compressor and pumps it out through a 1 millimeter annulus around here. And that creates a negative pressure over this aerofoil section, which sucks in air from behind. And then it expands slightly and therefore creates more negative pressure. So you've got a huge suction here. And then you get something called viscous shearing here. So you end up multiplying this original airflow about 20 times. So you get something for nothing just by having a few interesting shapes.
I feel like I'm talking to someone at Boeing or something. It's like as if you are creating an airplane.
Well, it is a little bit like an airplane, in a very modest way.
And tell us about, this is the heater?
This is the heater, which uses the same principle, but has barium titanate semiconductors in here, which are not as hot as resistance wire. You know that when you turn fan heaters on, you get that smell of burning dust. Right. Because the resistance wire is quite high temperature. This is much lower temperature, and so you don't get a burning smell. And of course, you can touch the heater. So, it projects the air, the hot air very well, so it heats a room up quicker than a normal fan heater, and uses slightly less electricity. And then we talked a bit about the air blade.
Yes. And now all of the new vacuums are working on this ball technology.
Yeah, because I thought vacuum cleaners were heavy, and because they've got 4 wheels, they're difficult to steer because you keep having to go backwards and forwards and then sort of do that to get round something. So we just put the motor and all the workings down in the ball, so it's got a very low center of gravity. And then you just twist it and go around, things like that. So
that's great.
It's just dead easy to use. And as I said, very, very, very light.
Yeah, indeed. So are you excited about some of the new enabling...
Do you want to know how to empty it? I didn't show you how to empty it.
Of course.
You take the bin off and then just empty it like that.
Yeah, I do have one of these, so I'm familiar
Right,
with that empty.
And you use the hose, do you,
Do.
to get into small places? Right.
That's the best. The best. I clearly need to upgrade my Dyson because you did that with much more facility than I do it at home.
Oh, good, good. So we made some improvement.
Yes, indeed. So there are all these exciting new technologies, of course, that are enabling rapid prototyping, like 3D printers. Do you use any of that technology at all?
Oh, well, of course. And actually, nothing beats going out and making a working prototype of something, which isn't necessarily a complete product. It might be a part of something. So we don't really use rapid prototyping for that. But and the trouble is that people tend to use rapid prototyping to do a sort of immediate example of what they've designed on the screen, and that's not very good. But what it's really useful for is doing lots and lots of prototypes, which you can go out into real homes and test and put onto user courses and put through mechanical test systems. So it's really useful for that, and enormously time-saving.
And if you were to choose another consumer product that really frustrates you now, what would it be?
Well, I'm not going to tell you.
Oh, come on.
That would be a giveaway. But I mean, almost everything is frustrating when you think about it. And anger is a great motivator.
Indeed, indeed. So tell us a little bit, you just quickly broached the idea of China moving into the marketplace and that you have several lawsuits going. What has been your experience expanding into that market?
Well, we don't sell there at the moment. We probably will. But we used to manufacture some things there, but we pulled it out. It's a great market, and I think I mean, the trouble is they don't buy vacuum cleaners because they have a servant who sweeps the floor. And they tend to buy Burberrys and Bentleys, which they can show off. So it's not, at the moment, it's not a great market, but it will be, and we are going in there. But there's many other, actually more interesting Southeast Asian markets for us, like Japan, which is a wonderful market, where they love technology and are very sophisticated, and Taiwan and Singapore and Malaysia. These are great markets as well. China isn't the only market there.
But you clearly are protecting your patents, and intellectual property is important to you as a product designer. And we talked a little bit before about open source design, and there's a movement towards that, which is kind of counter to intellectual property. And how do you feel about this new movement of open source design, where people are collaborating en masse on iterating new developments in product design, and yet, you really do have to protect your patent and your intellectual property if you have something that is radically redesigning a product.
Well, I think that patents encourage competition. If you didn't have patents and you couldn't protect what you did, no one would develop anything. There wouldn't be any point, because if you can develop something and someone copies it, you're going to lose money, because they haven't had the development costs, or for that matter, the patent costs. They just copy it, and they've had no costs. So you've got to have patents to create competition. So if I do something and patent it, someone else has to create something else to compete with mine, and they patent it, and we're in competition. So some people suggest that patents restrict competition. I think it's exactly the reverse.
Interesting. And then let's circle back then again to what your foundation is doing to encourage young designers and young engineers. I know you have a pilot program in Chicago. Yeah,
we're doing after-school clubs to teach them design and technology. So we give them vacuum cleaners to take to bits and put them back together again. And then they can make their own projects. And I've seen them do this, and it's wonderful. I mean, in 1 hour, a group of 3 children did a device to mince up kitchen waste and blow it outside into a bin, because they hated the smelly bin with the food rotting away in it. They got angry about a problem and found a solution to it. These are 11-year-old kids. It's great to see that.
It's amazing.
And in the after-school clubs, there was one boy who was absolutely hell-bent on being a lawyer, but now he wants to be an engineer.
You got him.
We got him. Only one, but it's a start.
That's great. That's great. Well, I really want to hear a little bit more about how you, what your prototyping process is like, and how you train your young engineers to not only accept failure, but to be real risk takers. I know that we spoke a little bit about how when you started out, it was impossible to get any money from venture capitalists because they were afraid of product. And so, I mean, the good thing is that now you call the shots, own the company, but that's a tough process, and you have always really encouraged risk taking. Can you talk a little bit about that?
Yeah, well, it's incredibly important. Yes, when I started, I went to venture capitalists to try and raise money, and they said, well, the vacuum cleaner looks quite interesting, but we're not investing in you because you're an engineer. Anyway, there's Mr. Honda and Akio Morita as examples of people who've been reasonably successful by being engineers. No, I think of course bringing out new products is a risk. It's a huge risk, and it isn't just the development costs. It's the tooling costs, the plant and equipment costs, the launch costs. Enormous amount of money. But it's exciting. It's fun, and if you don't do it, it's very dull. And also, if you don't do it, people will catch up. So it's absolutely essential to do it. And there are businesses that make their money by copying people. And then there are businesses that try to make a living by creating things. And I know which camp I'd like to be in. And engineers want to be, particularly young engineers, want to be inventive. They really want to change things and do things differently. And it's not very hard to get them to do it. I mean, just allow them to make mistakes. And when they have an idea, sitting around and talking about something, they have an idea, you just say, well, go and make it, go and try it. It won't work, but go and try it. No, it will work eventually, but don't be disappointed if it doesn't work the first time.
Right.
Find out what went wrong and then work out ways to overcome it. So it's allowing people to make silly mistakes, to make silly suggestions, obtuse suggestions, and not laugh at them. Just say, yeah, that sounds interesting, go and do it. The worst suggestions are the correct suggestions, the sort of obvious suggestions. They're just irritating. You've got, what we want is people to make, very obtuse and different ways of doing things.
So what other companies do you admire? Who else is taking risks right now?
Well, I'm so busy doing what I'm doing, I don't really look around at what other people are doing, but I'm sure other people are doing wonderful things. I'm keeping myself rather busy doing this.
Clearly. Well, thank you so much for being here. I think we'll take some questions from the audience and from our Twitter stream. The question here in front of me. Does product make the brand, or does brand make the product?
Well, there's only one word I banned in my company, and that's the word brand. I don't believe in it at all. You're only as good as the product you're making. People buy our product, they don't buy our brand. They don't buy our company. They're not interested in our company. They buy our product, and we're only as good as our latest product. So I don't believe in brand at all. Sorry.
Mr. Dyson?
Yes.
My name is Patrick Birmingham, a graduate of St. Martin's School of Fine Art. What did you learn at art college that still informs or influences the decisions you make today?
Well, that's a very good question. I went to a wonderful college called the Royal College of Art in London. It's called the Royal College of Art, but actually most of it is design. And I learnt about design. And design college, you can dream, you can build a product that you really like and have experts help you. You can go over to Imperial College, a famous science college next door, and get help. And so actually the best thing it did was to tell me that it's no good just being a designer. It's a slightly negative thing, actually. It's no good just being a designer. You've got to make a product that works better. So I went off to an engineering company for 7 years to learn how to do research and development. But I'd never have got there if it hadn't been for this college telling me about design and getting me to, well, A, dream and be ambitious, but also teaching me how to design things.
Hi, Barry Ritholtz, Ritholtz Capital Management. I love the clever application of engineering and the smart ways you apply physics, but I'm just curious about the day of James Dyson. Do you walk through life seeing all sorts of just terribly designed products and machinery? Like, is your life just, what is this piece of garbage that you're constantly interacting with?
Well, I'm delighted to meet a venture capitalist interested in engineering and science. I think you're the first one I've met. But, I think all engineers do that. You go around and, you want to know how something works. And if it isn't very satisfactory, it displeases you. And it's actually, it's inspirational. There's an opportunity to do something better. Why didn't they do this? So engineers just do that naturally, I think, like I presume doctors do when they see someone ill. So, and it's fun. But yes, it is annoying sometimes when you see something badly designed. There's an interesting thing about design is everybody thinks design is about how something looks. When you think of design, you think of someone in a pink shirt with felt-tip pens. But then when something doesn't work, you kick it and you say, who on earth designed this? So, and the latter form is really what a designer is. He's someone who not only makes things look good and last a long time and be of high quality, but also uses new technology to make them work better.
We have a Twitter question. How much of your time is spent managing versus investing?
No, I don't say I don't invest, but I just want to do new products. I often don't wonder about how much they cost. We just do them because someone does tell me how much they cost. But I don't manage at all because I'm a hopeless manager. So other people do what's called managing. And I go and be with my engineers and just get involved in designing, developing new technology and new products. So I'm lucky enough to have got to the point in the business where I don't have to manage anybody.
Oh, that's great.
Which is wonderful. I don't think I ever did anyway, actually. I mean, we just got on with things.
Maybe one last question. Anyone?
Thank you. Frank Gibney. You talk about being and you are an engineer, a wonderful engineer, but you went to the Royal College of Art. What is the difference between artists and engineers? And yeah, that's it.
Well, not a lot. They're both, trying to create something different. Yes, it is at Royal College of Art and Design, and I actually studied architecture, but not a lot. I think the same sort of. Sorry, I don't know where you're. Is that you there?
It's up in the balcony there.
I'd quite like to face the person who asked me the question. There you go. I think a designer or an artist is probably more interested in how something looks and the reaction you get when you look at what you're looking at. Whereas an engineer is much more concerned probably with what goes on inside and the technology being used and how reliable it is and how long it lasts and how much it costs. So I think for me, I couldn't be an artist because I need all those other complex issues to worry about. I couldn't just worry about how something looks, but that's how you're made up. David Hockney is brilliant and articulate, and he paints the most wonderfully inventive paintings. But I just worked out what made me tick and what turned me on, and it was engineering for me and developing technology.
Well, we're glad you went that way. Thanks so much.
Thank you.